Introduction to the new discovery. In an audacious announcement, researchers have stated that they've uncovered a planet unlike any we've encountered before. NASA, known for its groundbreaking discoveries, has revealed that this planet is intriguing, not only for its size and location, but also for the artificial light it emits. Could we be about to discover undiscovered facts that could fundamentally alter our understanding of the universe? Could this discovery point toward the possibility of life on other worlds? By delving into NASA's groundbreaking findings, we will soon unravel the truth behind this astonishing phenomenon. In 2007, NASA launched the Dawn spacecraft with the goal of exploring some of the most fascinating objects within our solar system. Fitted with 3 ion engines, Dawn embarked on a journey beginning with a 14-month study of Vesta, the second-largest asteroid in the belt. Dawn returned highly detailed images and data that shed light on Vesta's complex surface and diverse geological history. After completing its mission at Vesta, Dawn proceeded to the second phase of its journey, one that was likely even more thrilling, a comprehensive examination of the dwarf planet Ceres. Thanks to its ion engines, Dawn could break free from Vesta's orbit and head towards Ceres, a feat that would have been impossible with conventional chemical propulsion systems. These engines provided a steady thrust, allowing Dawn to travel vast distances and enter a stable orbit around Ceres. Discovered in 1801 by Italian astronomer Giuseppe Piazzi, Ceres is the largest object in the asteroid belt located between Mars and Jupiter. For 4 years, it was categorized as the smallest dwarf planet in our solar system until its reclassification in 2006. Ceres is the largest and most massive object in the asteroid belt, with a diameter of about 950 kilometers. One of the most captivating features of Ceres is its unique attributes. Scientists eagerly awaited the first close-up images of this mysterious planet, which revealed brilliant spots scattered across its surface, particularly in a large crater known as a Cater crater. These bright spots sparked immediate curiosity and speculation within the scientific community. Prior to the Dawn mission, the best images of Ceres were blurry, low-resolution shots taken by the Hubble Space Telescope. Very little was known about this dwarf planet, and the promise of detailed observations from Dawn fueled excitement among astronomers and space enthusiasts alike. The Dawn mission aimed to enhance our understanding of the solar system's formation and investigate the role of water in the development of planetary bodies. The bright spots on Ceres, also observed on other asteroids, might be made of highly reflective materials, possibly salts left behind by evaporated water. This discovery hinted at the possibility of cryovolcanism, volcanic activity that erupts, water or brine instead of molten rock. But what exactly are these enigmatic lights? And what do they reveal about the true nature of Ceres? Could they be evidence of something even more extraordinary or of ongoing geological processes? Ceres stands out from other objects in the asteroid belt due to its size, mass, composition, and the potential presence of water and ice. Unlike the typically rocky asteroids, Ceres has a more comet-like composition, suggesting it could unveil more secrets about the early solar system. After 2 years in transit, the Dawn spacecraft finally began its approach to Ceres in early 2015, marking a significant milestone as it prepared to offer the first detailed views of the largest body in the asteroid belt. As Dawn neared Ceres, the images became progressively sharper, revealing a world previously hidden from view. The initial photos showed a cratered surface, suggesting a long history of impacts. However, what drew the most attention were the mysterious bright spots amid the dark, rugged terrain. As the image resolution improved, scientists began to formulate theories about the nature of these spots. Could they be something even more remarkable, or were they simply areas of ice that caught the sun's rays? Speculation ranged from mineral deposits to possible signs of cryovolcanic activity. A closer look revealed to everyone's surprise that the brightest spot was actually a collection of distinct areas rather than a single feature. The theory that these were salt deposits left over from when water sublimated was the most commonly accepted. This suggested that Ceres had, or possibly still has, some form of geological activity capable of pushing water or brine to the surface, where it rapidly evaporates, leaving behind bright, reflective residues. These findings revealed a world that was more complex and dynamic than anyone had anticipated, challenging previous notions about Ceres. Our understanding of the possibility of life elsewhere in the solar system could be profoundly affected by the existence of subsurface water, or brine pockets. Ceres is often described as an icy world with a rocky yet porous surface. Unlike most asteroids, which are largely composed of rock and metal, Ceres stands out for its distinct composition. It has a structure that is less dense than that of its rocky neighbors because its surface is a combination of water, ice, and hydrated minerals like clays and carbonates. This composition suggests that Ceres may harbor significant amounts of water beneath its surface. Its outer layer is rocky but porous, with trapped ice and other volatiles, making it resemble a comet more than a typical asteroid. It is believed that Ceres has a unique internal structure consisting of a rocky mantle and a core rich in water ice, which makes up about half of the planet's total volume. Its mantle is likely a mixture of rock and brine surrounding a denser core, possibly made of silicates. The presence of substantial amounts of water ice raises the possibility that Ceres may have once supported liquid water, especially if its core was heated by radioactive decay during its early history. This internal composition sets Ceres apart from its neighboring asteroids and opens up fascinating questions regarding its potential for geological activity and the role of water in shaping its development. But that's not all. The discovery of ammonia clays on Ceres suggests that this dwarf planet may have originated in the cooler regions of the solar system before migrating inward. The presence of ammonia could lower the freezing point of water, making it possible for surface brines to exist. These revelations about Ceres's composition and history not only deepen our understanding of this captivating dwarf planet, but also provide valuable insights into the processes that govern the formation and evolution of icy bodies across the solar system. Cryovolcanism is a fascinating and uncommon geological process, especially in comparison to Earth's typical volcanic activity. Unlike traditional volcanoes, which expel molten rock, cryovolcanoes, also called ice volcanoes, release materials such as water, ammonia, or methane. These substances can remain in liquid or gas form in extremely cold environments where they exist as cryovolcanic activity on Ceres. Cryovolcanoes allow salty water to rise to the surface. When this briny water comes into contact with the vacuum of space, it quickly sublimates, turning from solid or liquid into gas. This process leaves behind glowing, reflective salt deposits that form the mysterious bright spots visible on Ceres. The spot in the crater, known as Spot 5, is the most well-known of these spots. This area has attracted significant attention due to its high reflectivity and periodic changes observed by dawn. Water sublimation is thought to be the cause of these fluctuations, which suggests that cryovolcanic activity may still be taking place or may have taken place recently on Ceres. Addition to Spot 5, Ceres hosts several other bright spots, each with its own distinctive characteristics. These spots aren't confined to one location, but are spread across the surface of the dwarf planet, indicating that cryovolcanism could be a widespread phenomenon on Ceres. The presence of these bright spots highlights the dynamic and active nature of Ceres, challenging the previous belief that it was a geologically dormant world. A surface marked by a variety of craters, each telling a distinct part of Ceres's history, was revealed by the Dawn spacecraft as it continued to send back more detailed images. The discovery of these features on Ceres truly revolutionized the way we view this dwarf planet. Ceres challenges numerous expert opinions and theories regarding new planets due to its icy composition and indications of possible cryovolcanic activity. No longer considered It is now regarded as an active and developing world rather than merely a frozen relic. Scientists continue to be intrigued by the bright spots, particularly in the R crater, because they may provide insight into processes that are not only geological but also linked to the planet's capacity to hold liquid water. What does this discovery mean for humanity? The study of Ceres has far-reaching implications beyond just understanding this particular dwarf planet. Researchers can gain crucial insights into the broader dynamics of icy bodies in the solar system by examining the Ceres' internal composition, surface characteristics, and nature of its bright spots. The materials found on Ceres, water ice, ammonia clays, and salt deposits, could offer valuable clues about the chemical makeup and environmental conditions of other similar celestial bodies in the solar system and beyond. In addition, the possibility of cryovolcanism on Ceres opens up novel perspectives on the broader geological activity of icy moons and dwarf planets, not only in our own solar system, but also on exoplanets. It suggests that environments that we had previously considered to be static or hostile might actually be dynamic and able to support intricate processes. Could this also mean that other distant worlds once thought to be frozen and lifeless could harbor conditions conducive to life? NASA's Dawn mission continues to stand as a testament to the power of space exploration. Our understanding of the formation and evolution of solar systems has already been reshaped by the information it has returned. As we probe deeper into the mysteries of Ceres and other distant bodies, each discovery adds a piece to the puzzle of how planets, moons, and other celestial bodies evolve over time. For now, the bright spots on Ceres remain one of the most intriguing phenomena in our exploration of the cosmos, but they are only the beginning. The Ceres, which at one point appeared to be an obscure and forgotten dwarf planet in the vast asteroid belt, now stands as a beacon of mystery and potential as technology advances and additional missions are launched. Its surface, its internal structure, and its enigmatic bright spots may one day provide the key to understanding the early solar system and the processes that led to the formation of planets and other bodies. The potential for life, or the ingredients for life on Ceres, remains an exciting possibility that continues to inspire researchers and space enthusiasts alike as we continue to explore Ceres and other distant worlds. The line between science fiction and reality continues to blur. The idea of life on other planets, once a subject of speculation and imagination, is now a real and serious question. Could microbial life exist in the underground water pockets on Ceres? Are the conditions on other icy moons in our solar system suitable for life as we know it, or even for life we haven't yet imagined? These are the questions that will drive the next wave of space exploration and may eventually unlock the mysteries of the universe in the years to come. As we look to send more spacecraft and possibly humans to explore these distant worlds, the discoveries of Dawn and future missions will shape our understanding of what is possible in the universe. From Ceres' icy surface to its bright spots, that may point to the presence of liquid water. The dwarf planet stands as a reminder that there is still so much we don't know about our solar system and the many wonders it holds. The mission to explore Ceres is far from over, and with each new discovery we come closer to uncovering the secrets of this fascinating world. As the Dawn mission continues to send back groundbreaking data, scientists are reevaluating many of their preconceptions about how bodies like Ceres evolve. The presence of bright spots and evidence of cryovolcanism points to the possibility that Ceres may have undergone a form of geological activity much longer than previously thought. Most celestial bodies of this size are assumed to be dormant after billions of years. However, the active processes occurring on Ceres suggest that its interior might still harbor pockets of liquid or briny water capable of fueling activity beneath the surface. This is a fascinating prospect as it challenges the idea that small planets or moons are incapable of sustaining long-term geological processes. The discovery of Ceres' potential internal water reservoirs opens up possibilities far beyond just this one dwarf planet. Many of the icy moons and planets in our solar system, such as Europa, one of Jupiter's moons, and Enceladus, a moon of Saturn, have been identified as having subsurface oceans. These moons are much smaller than Earth, but the presence of liquid, water beneath their frozen crusts, suggests that life might be able to exist there, even if it isn't the type of life we are familiar with. This realization has propelled astrobiologists to reconsider the idea that life requires specific conditions, such as the ones found on Earth. It may be that life in the universe can exist under very different conditions than we previously thought. Perhaps in the subsurface of icy moons, or even in the oceans hidden beneath the crusts of dwarf planets like Ceres. One of the most intriguing aspects of Ceres is its complex history, which is hinted at by its unusual features. The bright spots in a crater, which are believed to be salt deposits from evaporated water, are a strong indicator that the dwarf planet underwent periods of geological activity. If liquid water did exist on Ceres in the past, it could have been a vital part of a wider process of chemical and mineralogical transformation. The complex mix of hydrated minerals and salts found on the surface may suggest that Ceres has experienced significant changes over time. Such changes may have been driven by heat generated from internal processes, such as the decay of radioactive elements within its core or the impact of space weathering. In addition to potential signs of cryovolcanism, Ceres' surface is also marked by numerous large craters. These craters provide a geological timeline of the impacts it has experienced over the eons. The impact craters tell us much about Ceres' early history, as they have shaped the planet's surface and are crucial for understanding the bombardment period that affected the early solar system. Studying these features can provide important information about the distribution of mass within Ceres and help scientists model its internal composition more accurately. Furthermore, Ceres is of particular interest because of its location within the asteroid belt. Ceres is located in the middle of an area teeming with rocky bodies, in contrast to other moons and planets in our solar system, which revolve around larger planets. Its presence in this belt means that it may have once played a key role in the early solar system's formation, potentially helping to shape the distribution of other bodies in the region. Scientists are also using data from Ceres to test models of how planetary bodies form in the presence of gravity and various materials. These models can help to shed light on the processes that led to the creation of the planets we know today. The potential for future exploration of Ceres is vast. With new missions, including the possibility of landing on its surface or drilling into its icy crust, there may be even more groundbreaking discoveries in store. These future missions could focus on exploring Ceres' subsurface, examining the properties of its frozen and liquid water, and investigating how its geological processes work in greater detail. The unique combination of features on Ceres makes it an exciting target for further exploration, and its findings may help us understand more about the conditions needed for life elsewhere in the solar system. The study of Ceres may also shed light on the broader idea of habitability. While Ceres itself may not support life as we know it, understanding its composition and geological processes could give us a better understanding of the ingredients and environmental conditions that may lead to life in other distant worlds. The possibility that life could arise in environments vastly different from our own is an exciting thought that drives many of the ongoing scientific endeavors. Whether in subsurface oceans or in environments characterized by extremes of temperature and pressure, Ceres provides a critical piece of the puzzle in our search for extraterrestrial life.